Hey everyone, today we're looking at section 0.4.1, which is Law of Exponents. So first thing you want to know is that some vocabulary. So if I have 2 to the 5th equals 32, 2 is what we call the base. The base is what's always raised to the exponent. And the 5 in this case is the exponent. And then we call 32 the value. There are 5 law of exponents, and law of exponents basically simplify problems involving exponents. So the first law of exponents is when you're multiplying equal bases. So if I had, for example, x to the second times x to the fourth, notice I'm multiplying like bases. They're both x's. Well, if you remember, x squared is x times x. And x to the fourth means x times itself 4 times. And so I don't really need these parentheses there because I just wrote that to note that x squared is x times x and x to the fourth is x times itself 4 times. So I can really just write this as x times itself 6 times, which is simplified to x to the 6th power. So I don't want to be writing all these x's every time. So that means our law of exponent is that if you have the same base and they are being multiplied together, so for example, if I have x to the a times x to the b, I can make that into a single base. In this case, our base is x, by adding the exponents. So this would be x to the a plus b power. And if you notice, that's what happens here. I have x squared times x to the fourth. I made that into a single base of x, and I added the 2 and 4 together to get 6. Okay, so that's when you multiply equal bases. Again, this base could be numbers, it could be variables, anything. As long as the bases are the same, you can do this. Next one is dividing equal bases. So, for example, if I had x to the 5th divided by x squared, well, like we just said, x to the 5th is x times itself 5 times. X squared is x times itself 2 times. And whenever you have factors separated by multiplication, the same factors on the top as the bottom, remember they can cancel out. So one of the x's on the top would cancel with one on the bottom. A second on the top would cancel with a second one on the bottom. So we would be left with x times itself 3 times in the end, which is x to the 3rd. And so our second law of exponent, in more general terms, is x to the a power divided by x to the b power. So again, notice the bases are the same. I can make that into a single base of x by subtracting the exponent. So x to the a minus b power. Law of exponent number 3 is where you're going to raise a power to a power. So you're going to have base, for example, I'll have x to the 3rd, and then that's going to be raised to a power. So I have like 2 exponents here. And so if you remember, if we're going to figure this out, squaring means to multiply by itself. So in this problem, we're really doing x to the 3rd times x to the 3rd, which goes back to the law of exponent number 1, where I'd add those exponents, which is x to the 6th. Now, the shortcut here is I don't want to have to write this like this next time. So how do I get to 6 from 3 and 2? Well, I multiply those numbers together. So there's our shortcut. If I have x to the a raised to the b power, I can keep that single base of x and just multiply my exponents together, x to the a times b power. Now, sometimes you may have more than one base raised to that additional power. So, for example, if I had, say, 2 x to the 3rd, and that's all raised to the 4th power. So now the 2 has to be raised to the 4th power and the x to the 3rd has to be raised to the 4th power because they're both in parentheses. Now remember, if you don't see an exponent, remember this is really a 1. So what that means is I now have to multiply the exponent of 1 times 4. So I'd end up with the same base of 2, but 1 times 4 is 4. So 2 to the 4th times my same base of x. 3 times 4 is 12. And then 2 to the 4th is 2 times 2, which is 4, times 2 is 8, times 2 is 16. So I end up with 16 x to the 12th for this problem. All right, if you go to the next page then, we come to law of exponent number 4, which is involving negative exponents. And to get negative exponents, I'm going to do a little trick here. So if I had x to the 3rd divided by x to the 5th, using law of exponent number 2, I subtract my top number from my bottom number. So 3 minus 5 is negative 2. So I made that into x to the negative 2nd using law of exponent number 2. Now, if I write this out, x to the 3rd over x to the 5th, that would be x times x times x. X to the 3rd is x times itself 3 times. X to the 5th is x times itself 5 times. And again, these are factors, so I can cancel all 3 of the factors on the top with 3 of the x's on the bottom. And so I would be left with 1 over x squared. So what that's telling me is that x to the negative 2nd is equal to 1 over x squared. So the bottom line, the law that we're going to put in this box, is to make a negative exponent positive, move it to the opposite part of the fraction. We'll say move the base to the opposite part of the fraction. So, for example, here's another example. If I had 3 x to the negative 3rd y to the 2nd, remember, only negative exponents move to the opposite part of the fraction. So this 3 that's a base really is, remember, raised to the 1st power. That's a positive exponent. So I'm still going to have 3 on top. I'm still going to have y squared on top because that was a positive exponent. But this negative 3, I want to move that to the bottom to make it positive because you can never leave exponents negative. So I'd have 3y squared over x to the 3rd as my simplified answer. If I do one more, do this one, another example. If I have 9x over y to the negative 5th, again, remember, the 9 is really raised to the 1st, the x is raised to the 1st. Those are already positive exponents, so I'm going to keep them up top where they belong because they're not already positive. But this negative exponent I can't leave. Therefore, I move it to the opposite part of the fraction. So since it's on the bottom, I'm going to move that base up top with the 9 and the x. And then once I move that up top, that exponent becomes positive. So this is the same as 9xy to the 5th. And then our final law of exponent is the 0 power. And to note this, what we're going to do is if I do, say, x to the fifth divided by x to the fifth, using law of exponent number 2, I subtract. 5 minus 5 is 0, so that will give me x to the 0. If I actually wrote that out, I would have x times itself 5 times on the top, x times itself 5 times on the bottom, and all of these x's would cancel out because they're all factors. And remember, when things cancel, they equal 1. So therefore, x to the 0 equals 1, which is ultimately telling me any number to the 0 power equals 1. And for that matter, any number, and we can even say or variable, raised to 0 power is 1. Anything raised to 0 is 1. So I could have, as our example, I could have 5,456,987 x to the second, y to the negative fourth, z to the ninth. Pretty crazy, right? But it's all raised to 0. Guess what it's equal to? That whole thing simplifies to 1. So as you go here, try this open middle problem. It says use the integers 1 through 20 at most one time each to fill in the blank. So you're not going to use every number, but you're trying to make equivalent statements using numbers 1 through 20 in here. You want them all to be equal in the end. And again, use law of exponents to help you out, and there is more than one answer possible.